very strange past year and a plenty strange year that seems to be going on. I'm particularly thinking about 2 months ago when everybody thought that it was summer and then it turned into winter again. But of course some people planned it in Iowa and all of that sort of thing. A lot to talk about, but let me go back to the persistent heat in the summer of last year. The chart that you're looking at has some black areas, which mean more than 70 days with temperatures over 100 degrees. That got to be downright warm if you were in the Texas-Oklahoma border area and some other places such as Death Valley where it was not too uncommon. The other kind of thing that we see on this picture is some little spots indicating between 1 to 10 days with temperatures up in the 100 degree area. And that was extraordinary. This is the first time in 40 years of watching this every year that every state has had temperatures over 100 degrees. So it was an extraordinary year, but it was especially extraordinary for people in Oklahoma and Texas. The heat was there. There was just no question about it. Let's move into summer. When we came into the summertime, we had another interesting effect going on. That's very warm in the Corn Belt. Just essentially everywhere you went in the Corn Belt, more heat than you really wanted. It was colder than usual in Washington. It divided just about on the Continental Divide. When that happens, it can be very persistent to remain cool to the west of the Continental Divide and hot to the east. And it works the other way around as well. Whenever we see a major weather pattern dividing on the Continental Divide, we realize we have a weather pattern that could stay with us for weeks and weeks, if not months and months. And that was the effect that we had this past year. The area you see in red, of course, took the real beating that week, but the high temperatures in this area. Now, there's an effect that's called the Madden-Julian effect, and you're seeing this on my motion picture here in red. And I was watching this, and I knew that they should be one of these red areas every so often around the world, and that it was only a matter of days until one appeared in the center of the U.S. And so here we are in February and March, and it begins to develop in the center of the U.S. And now we're into our warmest March of this year in history. Not the highest daily temperature, but the warmest March temperature for all the area in the center of the United States that will get the red wave of heat into there from what we call the Madden-Julian effect. So the heat that we'd had the previous year now had a secondary effect with a further than usual to the north Madden-Julian effect. The scientists that studied this kind of thing originally settling in the center of our continent as we came into February and March in this year. And so here was a heat wave, I guess, for all of us. The daily temperature deviation from average during the past almost 2 years now, I've got expressed on this chart. This immediate past year, right up to yesterday, in red. And in blue, we have last year. The thing I want you to notice is 20 degrees warmer than usual, 30 degrees warmer than usual. There was our 17th of March. The year before, we were having a warmer week than usual. We had a cool week, a warm week, a cool week. These are the warm ones. These are the cool ones. down at the bottom. This was a very dramatic effect of the deviation from usual in staying about a week of warmer than usual, about a week of colder than usual, and a very strong effect. It was not hot all of the time during the past year and a half, but it was La Nina. And La Nina gives extremes in both directions. Extremely cold when it's cold, extremely warm when it's warm. And that is the effect of La Nina in the center of our continent. And you see it just switch back and forth. You can see my red hashes at the top and blue at the bottom, and they just alternated. And it's continued to do that this year right up until yesterday, which is the end of the red line over here to the little bit off the center of the picture. And so there's yesterday. But the pattern's still changing. Warmer than usual, cooler than usual, warmer than usual, cooler than usual. A warm run that we had there. Well, yes, beginning 17th of March, we had a very extraordinary time this year with heat in the month of March that set records for the Midwest. And I don't know if we expect that record to be broken again, or if this is going to be a trend of things to come, like a lot of climate change people think that it may be. Well, we just don't know. Let me talk a little bit about the crop yields. First, looking at Iowa, there's several things on this chart that are important to you because I think everyone in the room is interested in national corn yield. This for the state of Iowa. Here at the bottom we see a blue series of data, and this is our national yield. And here we have Iowa's yield and central Iowa's yield. So running up in this area and the central running about like the state and following the pattern of the nation and an equation that goes with it. And we see an interesting number here. Central Iowa corn yield plus 2 bushels per acre per year is the increase rate that the state is going through. And I want you to pay attention to this dashed blue line. This is the high yield for the state of Iowa. And it's consistent difference from the trend line yield. When we have it, it's a straight line all the way back to 1937. When we have a high yield year, it tends to go up and hit this dashed line. I call the dashed line the realized potential crop yield. And that is the yield that we will have when nothing goes wrong. That's the potential crop yield for the corn in the state of Iowa with the soils in Iowa. If nothing goes wrong for the year, the yield touches that dashed blue line. We have one of these for every state. And this is a significant thing. This is the highest yield that we have been able to recognize, and it has a linear increase since 1937 right up to the present time. It just happens to be a straight line. If we have a great year, the yields of corn go up and touch that line. The trend, of course, is something lower than that. Here are the trend lines, in this case for central Iowa, for Iowa as a whole, and for the nation. And there is a trend line, and it is up primarily because of corn breeding and good management that goes with it. And so the yield continues to climb, and we continue to have high variability some years, such as we did back in the 80s and into the early 90s, and then the variability went away, and we've had consistent yields since then. Western Iowa, I've put on here just to show that they do about the same thing, but they have had the greatest yields in Western Iowa during the past few years. And of course, land prices have gone way up there. The reason that this happened is an increase in precipitation. Western Iowa's always been a good place to raise crops. It just hasn't always had good weather for raising crops. Hasn't had sufficient precipitation. Some places have irrigated, but now the precipitation has improved things greatly. And so they have shown a great increase. Western Iowa, Nebraska, South Dakota, North Dakota have increased because of an increase in precipitation during the growing season. There was a same increase in precipitation, of course, in eastern Iowa, but they already had enough. The same increase in precipitation for Illinois, but they already had enough. Extra moisture is to the point that it didn't help much. A pattern that is worth paying attention to. The trend line of high yields that we were just talking about is there at the top. This is the yield that the crops hit during the very best years. And we'll be very surprised if the Corn Belt or any individual state breaks their dashed line, because this is about the potential yield that we have with the weather that we can expect in this world. We've had fairly consistent yields for the past 16 years. A high year in there, no real low year. During the previous years, we had a lot of variability, 25 years of high variability, preceded by 18 years of consistent yields, preceded by 25 years of high variability, preceded by 18 years of consistent yields, preceded by 25 years of high variability. This has been a pattern that we didn't recognize until recently, that ever since we started keeping the records back in 1865, we've had times of high volatility years that go on for a period of about 20 to 25 years. And then we'll go 18 years with consistent yields. Not necessarily great, not poor. And then high volatility of yields, and then consistent yields. Why am I pointing this out? These consistent times have been the same number of years. And the times in between have been the same number of years since 1865, when we started keeping good records of corn yield in this country. Now there's another thing that I want to point out, this from the Ag Economist. Chad Hart gave me this graph, and this graph shows the seasonal price of corn, the cost per bushel, and this is sort of an interesting thing with the price of corn, and as the years go by, we've had a lot of variability in these things of cost of production and the cost to buy corn. So the cost per bushel to produce corn and the yields that we get. Well, we've had a good selling price for corn for these past few years. The costs have stayed down here. We do not expect this to continue. It never has in the past. The costs always seem to come up about to what we sell corn for. Or do we sell corn right down at the cost of production? This is a very important thing to notice. if you average this chart over its history, the cost of production and the cost of buying corn are within a nickel. We sell corn for the cost of production in this country. Some weeks it's higher than the cost of production, some weeks it's lower. But what kind of business do we have as farmers in this nation? We produce and sell corn. We sell it for the price of producing it. That isn't the way that most industries run. Most of them like to make a profit. But here we see the selling price of corn and the cost of producing corn. So you look at the blue line, and we've been selling for we've had a profit coming in over the cost per bushel for the past few years. We do not anticipate that this will continue. I was talking to my mom, a few other people in their 90s, and they said, we don't make any more on the corn now than we used to not make on the corn. Well, now we see the reason for that. If we always sell corn at the cost of production, you're not going to make any more on it these days with these great high yields than we did back in the early 50s when the national yield was many bushels less, on the order of 30 bushels the acre, instead of up around 130 bushels the acre. The increase in the yield of corn did not increase the profits to the corn producer, because we just keep selling corn at the price of production. And that will probably go on again. At least we'll be very surprised if it doesn't. So the corn price, selling price versus the cost of producing corn have been about the same, as you can see, over a period of time. There's one, how could we stay in business doing that? Well, that's because the cost of production does include the cost of labor. So farmers have been making their labor on selling corn, but not making a return to the business of farming. And so there hasn't been really a business return, there's just been a cost of labor return. Now let me get back then to the corn yield and these equal times here that we have of what the variability of the yields were, and for these periods. We're in stable period 4 right now, and all of the stable periods are the same length, and the unstable periods are the same length since 1865. I don't know if they're going to stay the same length, but it looks to me like the odds are on the side of putting an end to this stable period of production about now. So we cannot count on stable crop yields of corn or of soybean, by the way, during the next period of years, 25 years. In fact, we can count on a very unstable period as we approach 2025. At least that's the way it's been for the last 200 years, that there comes this period of time, and of high volatility. And that is the highest volatility of the century is likely to be around 2025 if the weather keeps doing what it's done for 800 years. That we know that from tree rings. A little bit on the reports of the yields this past year around the nation. The red areas had less corn yield this past year than they did the year before, and the blue areas did a little bit better. Also, I like to notice up in the great Northwest, the state of Washington and Oregon, that their yields are very high up in that area. They're dealing with 229 type bushels compared to 172 here for the average. You just don't compete with the state of Washington in yield per acre. Of course, that's irrigated corn. And they have warm days and cool nights. And as long as they have warm days and cool nights, their yields, that will extend their growing season, the corn fills. If we have warm days and warm nights, it will compact the season of corn filling. So you don't have as many days for the corn to fill. They got extra days there because the development of the corn slows down at night, as does development of other crops as well. Now, let me talk a little bit about the crop forecasts for corn. This is important to everyone that sells corn. It's important to everyone that buys corn. You're seeing here the yield per acre in last year and the year before. In this case, I think I put Iowa's on here. And what they anticipated the yield would be. I've got a red circle around it down there at the bottom, 177. And what the yield turned out to be, which was 172. We had some interesting things happening there. Oh, I'm going to go back to that chart if I can. Notice the underlined things at the top. Crop forecasts in this report are based on conditions, in this case on August the 1st, and do not reflect weather events since that time, nor do they allow for weather events to the end of the season. The forecast that they'd given at the bottom, circled in red, of 177 bushels the acre, was based on the yield that we would have if we had average weather until the end of the growing season. If you have wondered why the USDA crop estimate is almost never correct, that is the reason. It is based on having average weather from the day the outlook is given until harvest time. And then they would be correct. But sometimes the weather is better than average. Sometimes it is worse. Last year, they said 177 bushels, came out 172. The weather wasn't as good as normal from the date of their observation. But this is a very important thing that the USDA does. They say this will be the yield if we have normal weather from the day of observation till harvest. This is an advantage for the agriculturist. This is not an advantage for anybody else. Why is it an advantage to the farmer? Because the farmer can look at what the weather is doing to the crop, and knowing from experience what it does to the crop, and then have a conception that, all right, if we had average weather, we would get 177 bushels, for example, per acre. But we are having temperatures that are running a little bit high in the day. And there's a little bit of stress on the crop. So we're going to be lower than that. Or there's no stress on the crop. It will probably come out higher than that based on average weather. So the person that understands what is going to be happening between the date of the USDA report that comes out each month and what the weather has done since the report was formulated, about 2 weeks before we see it, and what it will do till the end of the season will tell us how much above or below that estimate the crop is going to be. So if you just say, well, the weather is better than usual, the USDA outlook will be low. The weather is worse than usual for the crop, the USDA outlook will be high. It isn't really their expected yield, it's the yield you would expect if you had average weather from the day they give the announcement till harvest time. Now, last year, we had extreme maximum temperatures, particularly in Kansas and Oklahoma, July the 10th through the 16th. This is just about the most important time to the crop. And here they were having, in the southern portion of the Corn Belt, southern Missouri, and on down into Texas, they were having extremes of temperature. Well, they were still extreme, even in Iowa, above normal. You see a couple of bullseyes on there in sort of orangish, pinkish color, depending on the projector, of the places where the extreme temperatures were up over 110 degrees. And whenever the temperature is above 93, it is a disadvantage to the yield of corn. 92 is corn's optimum temperature. After the temperature goes above 92, it is always a disadvantage to the crop yield. It will hasten maturity, it will reduce the hour-by-hour production as well. So here when we see these high temperatures, we know that it will be well above ideal for a crop. Night temperatures have an effect as well, but the extreme maximum temperature, here it was July the 10th of last year through the 16th. I looked at some annual climate records, and the spots you see in yellow had the driest summer, really the driest year, 2011, since those weather stations had been in operation. Most of them from before 1950. So all those yellow places, the yellow dots were experiencing their driest summer. And the red dots, their hottest summer. Hot and dry is not a key to success of a crop. Notice that very close to where we were having these driest years in history of the weather stations, it's where we were having the wettest year in the history of the weather stations. It's not very far apart. But it is typical of what goes on during a La Nina year. La Nina can be expected to be wet in this area and dry in this area. We had the coldest year in history in parts of Washington and Oregon, the hottest year in parts of Texas, Florida, and New England near the coast. There's an interesting thing right here in South Carolina and coastal Georgia. In South Carolina and coastal Georgia, we had at least one station that was their driest in history and one that was their warmest and several that were closed. This was not necessarily related to what was going on over here. This was a clue to what might be happening this year, the following year, the year we're in now, moving up into this area. At least typically it does. When they have this extreme in South Carolina and into North Carolina, it typically moves into the Corn Belt the next year. They've been seeing some of that effect. It's just one of those kind of warning things. If you live in a Corn Belt state, we have records of the weather stations near you. This is just an example in Iowa of a farmer that asked me a question who was located here. I said, well, you got a weather station there and one there and one there. In this case, Grundy Center, Marshalltown, Eldora, that have long-term records. We pay attention to those and look at the stations around your farm, and you can kind of get an idea what went on halfway in between the existing weather stations. Now for the entire Corn Belt. You can get these graphs. This is worth paying attention to if you are interested in what the corn yield is going to be in your area. In this case, we're looking at Sheldon, Iowa, but we have these for the entire Corn Belt on the website that you see here in boldface. Mesonet.agron, meaning agronomy, IA State, meaning Iowa State University.edu. So on this website, this information is available for the Corn Belt. You click on the state you're interested in. You'll get a map that shows the spots where we have weather stations. You click on that spot, and then you can see things such as the heat stress that might be affecting the crop. The normal heat stress, the red line. The heat stress that went on last year, the blue line. So you can see how it compares to normal. And the stress each day is at the bottom of the chart. The precipitation, the normal accumulation of precipitation. I begin with May 1 on these charts. You can start wherever you wish to on the charts for the area you're looking at. It might be planting date or normal planting date. So you pick the date that you want to start. You will then see the normal precipitation for that location over the years of history and what's gone on so far this year. Basically, we begin at planting date is a useful time to begin. And so on these charts, you can see on the one on your left, the heat stress as compared to usual, and the precipitation on the right as compared to usual. And when we went through June, we had a situation that was bringing us near normal precipitation accumulation as the weeks went by, and it stopped in the middle of July. We picked up a little bit of precipitation in August, and it stopped. Didn't stay up to normal. So last year we had normal precipitation up to the middle of July, and then it essentially quit and didn't stay on the normal line. We had some heat stress, no heat stress, some heat stress, and a little bit after that, but this didn't have moisture to go with it. So the plants weren't enduring it as well as if they would have had the moisture coming along when the heat stress was there. Still, it was heat stress. You can get a map for each of the Corn Belt states that shows the precipitation to date for many of the weather stations. Here we're looking at this year's precipitation. And the precipitation to date in northwest Iowa, adjacent Minnesota, 17 inches, almost 13 inches, almost 15 inches, over 14, normal for that site. The normals are all on this same website. The normal being 10, so 4 inches above normal. In southeast Iowa, they've had 10 inches of precipitation. Normal would be almost 15. The dry side of Iowa has been wet. The wet side of Iowa has been dry. Kind of a curious thing for the year to date. And here's where you see these things. Go to the Mesonet site, click on Ag Weather, and you see these things for the state that you wish. In 2011, the corn yield in the state of Iowa did very well in these areas, fair in the blue areas, not too good in these, and poor in the light blue areas. So these are the areas by county as the USDA reports the corn yield for the year. We're seeing some variation. I want to point out when I was a kid, 1947, you're looking at the snow, there's the tracks, there's the snow, here's a 6'6" man with a hat on. The snow was deep in 47. The snow was deep in 83. We had lots of winter snow in those years, and we haven't had so much since. Here was the standardized index that we had back from 1950 up to 1980 and since. This index showed a change from these years up to the later years. The whole trend moved. This is called the North Atlantic Oscillation Index. It has to do with the precipitation in a year being sometimes low and sometimes high, sometimes low recently, sometimes high, and the pattern that it goes through. And this pattern is related to where the Gulf Stream goes after it leaves the Gulf of Mexico. Does it hug the U.S. coast or does it head for England? When it heads for England, they do just the opposite of what we're seeing here. So we have had then some years with a very, very different effect recently than we had back here, and we're moving into it again. From 1980 to 1990, there was high variability in the weather, and then the index was fairly uniform for us since that time. This does more to tell us about when the dry periods are, the extreme periods, than any other tool that we have. The heat of the summer, in this case for Ames, Iowa. Here we had a time of warm winters. This is the amount of heat required to heat your house. And here were warm winters, here were cold winters. Here's the coldest winter here in the Ames area, about 30 miles, 40 miles north of us. And we had a year that was comparable back in 79. But overall, we went through a pattern of warm winters, cold winters, warm winters, cold winters. It goes through, there's a lot of variability, but there is a pattern. And the pattern for the winter temperature is a meaningful pattern for what's going to happen the rest of the year as well. But the main thing to pay attention to is that there is a pattern that gives us 20 years of one extreme, about 20 of another. These are associated with the sea surface temperatures. The sea surface temperature anomaly, warmer than usual, colder than usual. When the ocean is warmer than usual here, we have what's called the El Nino, and when it's colder than usual, we have the La Nina. These change the high and low pressure areas of our world. High pressure where the ocean is cold, low pressure where it is warm, and low pressures and high pressures space themselves out and either bring us years of likely harsh weather or likely mild weather. And this has been a factor that has gone on with us now through the last couple of years. We had what we call the SOI, measure of what the difference of pressure is across these areas of the ocean, going from a very high level to near neutral. Neutral is average weather. This is the La Nina weather. And here's where we are now. When we look at these things over history, we see some years that we can identify where the bad years and the good years were. We can see things like 83 and 88, and the years that were really rough years, and coming in a pattern that sort of follows the way my arrow is going. And right now, moving back up toward this pattern as we go out of the picture. The U.S. Drought Monitor last November showed that drought that had really been a plague down in Texas and Oklahoma was now joined by drought, if not an extension of the same one, that went up into Canada, including Iowa. So we went through what would be considered a droughty condition in the fall, and here it is as of now. Eastern Iowa, still in a droughty condition, and at least in the short term, in a long-term droughty condition into southeast Minnesota, and some droughty conditions elsewhere creeping into the Corn Belt. This is of significance to us. This in the southeast is of significance, especially if it starts to expand, and of course this is a very new outlook that comes out every couple of weeks. The moisture index for the crops, near normal if it's white, then nothing there. Dry if it's orange or yellow, wet if it's green. This is the area that has received so much precipitation during the early spring, and this area. And now it seems to be shifting a bit. We shall see. You can also get from this same weather chart that you were looking at earlier a comparison of the drought conditions for each state, looking at Iowa in this particular one. This was November of 2011, and the areas that were considered dry until we got to mid-May of 2012. And moisture had greatly improved here. Let's look back a year ago. Moist there and very moist throughout these areas. So the soil moisture, county by county, actually township by township almost. The little marks aren't exactly townships, but they're as close as we could come. I'm remembering Algona in 2002. We had a dry year, if you will, for soils, and here was Algona in 2002. The normal precipitation is the red, the blue it was lagging, then suddenly it caught up when we got to August. The heat stress came in July and then it didn't get any worse, and the growing degree days lagged usually and then caught up to normal. We had a La Nina as opposed to El Nino. That began in June of 2010. It peaked in November of 2010. It was the second strongest since 1950 by time and strength. It weakened, but did not establish neutral conditions in June to September of 2011. Then it strengthened again to a moderate La Nina. La Nina is associated with our extremes of weather in the Midwest. It's associated with our worst yield years. Some of the years can be all right during a La Nina, but it is rare. Then it ended likely on the 22nd of April of this year. And we would assume that this very strong La Nina that resulted in the crop problems of last year in the Midwest will cease to have an effect this year. We are now in neutral conditions. I've made some little graphs here for you to look at. Red is considered drought. Green is record high yield. Average yield is where yellow meets blue. In a year of neutral conditions, which we are in right now, there's about a 50% chance of being on the high side of normal yield and about a 47% chance of being on the low side. When we were in the La Nina last year, there was a 70% chance of a below trend yield. If we move into El Nino, there's a 70% chance of an above trend yield. Remember, trend is where yellow meets blue, green is near record high, red is drought. And so right now we are expecting this for this growing season, and about a 50-50 chance of being a normal year. There's a chance we could have a record high yield. There's a chance we could have a disaster, a drought. But this is the odds for this year, as we see them right now. The chance of having, up here in record high yield, a little bit above the chance of having a drought, or 10% below trend yield. So these are the outlooks as we see it. Now, the corn-soy outlook I put together from the work of 3 people. Dr. Wisner, historically, has done a very good job of knowing the likely price of corn at harvest time based on yield. Dr. Volter has done a very good job of telling us if we're going to have an El Nino or a La Nina or something else that has a big weather effect. And my work has been on what will our likely price of corn be and our likely yield per acre as we go ahead. And using the information of these other 2 people, we've been able to put together a pretty good corn-soy outlook, what I call the Taylor, Wisner, and Volter outlook. So when we were in May, here were the chances for this year. I just wanted to go back and look at these a bit. There was a 30% chance of a La Nina persisting into the summer. It is now gone. Then there was a 20% chance of going immediately to an El Nino, and we have not had widespread drought in the Corn Belt during an El Nino year. And a 50% chance of being neutral. Well, with those chances, here are the yields that would go along with that. A 30% chance of a yield less than 148 bushels. But the La Nina has gone away. So now the chance of being a U.S. yield of under 148 bushels with a corn price around $6.60 is now essentially non-existent. The 20% chance that we had of being in the middle with 168 bushels to the acre yield and $5 corn at harvest time has now increased to about 50% as this one went away. And the 50% chance of being neutral has stayed with around 164 bushels the acre corn yield and worth about $5.50. Now those prices will change with world conditions. We try to update them every month. But these would be the odds for the year as we see it. So here is the preliminary corn yield risk for this nation. This was the one we did in March, and there's a new one being generated almost as I'm speaking, that we would expect most likely yield of 164 bushels to the acre of corn for the national corn yield. And we would expect that that would be worth about $5.15 per bushel at harvest time prices. There are odds the other way. Yes, it could be a low yield with prices up around $6.60. It could be a high yield with much lower prices, but this being the most likely right now, near 164 bushels the acre U.S. corn yield. Bringing things right up to date on where we're at. Remember, this was the La Nina of the past couple of years. This is neutral territory. We are neutral. Moving into the almost assured high yields of an El Nino, not looking too likely. We seem to be holding in this blue area and probably will for most of the growing season. And with the risks that go with not being in the El Nino area, but being neutral. When we are in neutral conditions, there are some other things that can affect us, such as a low pressure up in the Gulf of Alaska. The low pressure in the Gulf of Alaska can bring dry conditions to much of the Corn Belt. It's done this in the past. And there's some possibility it's going to do it in the near future because low pressure has been hanging around there. But as far as El Nino and La Nina go, we're expecting the average year. South America is affected about the same, and as in southern Brazil and Argentina as we are, it's just that they're 6 months different. And they've been looking at the same possibility of having a normal season beginning now, and it seems to be doing so. The satellite picture from yesterday and shows no great storms coming our way, but a low pressure here that is near the Gulf of Alaska. We don't know if it will stop there or move right across. Some cloudiness here in the Midwest, not much. Not much in South America, not much in Australia, lots of storminess in China and in the Far East in general. These are updated twice a day. The outlook for the next 10 days. Warmish, the left-hand chart, for all of the areas that are in this cold in the blue areas, warm in the rusty-colored areas. On the warm side of usual, on the wet side of usual for the green areas, on the dry side of usual for the brown areas. The outlook for the 10 days, not too different from what it will be for the 15-day outlook either. But this, the encouraging thing. June, remember, is the wettest month of the year in the Corn Belt. And we're expecting it for the rest of the month now to have a good chance of being even on the wet side of normal for the wettest month of the year. This is considered a good omen for the crop yields across the country. In many locations, the corn has been curling in the middle of the day. The corn curling in the middle of the day means that it's not gaining weight when the leaves are curled. They've been opening at night in most places. When they stay curled for 24 hours, pretty soon you start losing leaves and you start serious loss of yield. However, the outlook is not a negative thing at the present time, at least as far as the Weather Service is concerned.